Okay, for the set of problems that we have, the data I have from page 212 in problem number 3, where we have the classification according to degree as well as gender, and we have a combined total of 1,907,172 degree recipients. And for the questions regarding this data, we have in the first case, we're looking for the probability that the person chosen at random is a woman with a bachelor's degree. Okay, and the way you would read this is having the characteristics of gender is woman, and then with the bachelor's degree, so you're looking at woman and bachelor's, and so you're looking at this many degree recipients over in this category. So you have 775,424, and that is going to be out of 1,907,172. And so for a way that this could be written symbolically is that with the numbers as they are, the probability of woman with a bachelor's, you can have 775,424, again out of 1,907,172. And if you were to put this in decimal form, okay, this comes out to almost 40.7%. Now, in the case of what we have for item number 2, okay, we're looking at the probability that the degree recipient, okay, chosen at random is a man or one who holds a doctorate. Okay, and now with the word or, okay, now we have for the operative that is going to be for the union. Okay, and so we have for probability is to be a man or doctorate, and with this situation we are looking at the addition method. So you have for man or doctorate, you're looking at the categories, namely the men by the gender, doctorate by the degree. And so for what we have with the addition rule, we have the probability man, okay, so this will stem from the men category, and then we have plus the probability, okay, namely doctorate, and you're going to subtract, okay, those that happen to have both qualifications. That is, we have the men who are also doctorates. Okay. Alright, so for what we have among the data, okay, we have for, again, for the number of men in total, we have 808,801. For those with the doctorate, we have 46,024, and we're going to add these numbers together out of 1,907,172, and then we're going to deduct the number of those degree recipients who are men and who have a doctorate, and so we're going to level off the total by deducting 24,341 out of the total of all the degree recipients. So for what we are going to have upon replacements, okay, so for the men, okay, you have probability that we have a man, you have 808,801, again, out of 1,907,172, okay, and then the doctorates have 46,024, and of course leveling off, okay, for those who have both characteristics, okay, a man with a doctorate, again there were 24,341 of those. And so with the numbers that we have we're looking at 879,166. Out of 1,907,172. And if you were to express as a decimal, okay, this comes out almost to 46.1%. Now, for what we have in the third category, or the third problem, we have the probability that the person chosen at random is a man with a bachelor's degree or a woman with a master's degree. Okay, man with a bachelor's degree or a woman with a master's degree. Okay, and so we have in this we're looking at a little combination of union and intersections, and a little bit of a trick one, or at least a little different layout in comparison to the earlier problems we have dealt with. Okay, but we're looking at separating categories: man and a bachelor's, and you have woman and a master's, and these events are going to be mutually exclusive of each other. And now we're going to have for the probability, okay, you have the probability, this will be a man with a bachelor's, okay, and you have plus the probability that you have the person be a woman with a master's. Again, this hook symbol is in reference to and. Okay, so and we have again, so we have with the addition method. Now these events are going to be mutually exclusive. Now for what we have here, men with the bachelor's, women with a master's. Okay, going back to the numbers here. Okay, men with the bachelor's, you have 573,079, and then women with a master's we have at 301,264. Okay, so there is no overlap between the categories. Okay, and they are going to be mutually exclusive. And so, taking the numbers as they are, the probability that the recipient is a man with a bachelor's or a woman with a master's. Okay, we're going to add the probabilities for these possibilities together. And so for what we are going to have in total, we have a combined total of 874,343 such degree recipients out of the total of all the bachelor's, master's, and doctoral recipients. And so we have for that probability, we have this in fraction form, and if you were to express as a decimal, okay, we have for that particular outcome, okay, this comes out to about 45.8%. Now, in the case of what we have for item number 4, okay, we're looking at the probability that the person chosen at random has a bachelor's degree or a doctorate. So we have another couple of mutually exclusive events. Okay, so for this layout, we have probability of bachelor's degree or doctorate. Okay, so there's not going to be any overlap, okay, between these categories. Okay, so we have we're looking at the probability of the bachelor's, plus the probability that the person selected at random is a doctoral degree recipient. Okay, and so for the probability of the bachelor's, okay, and this is not gender specific, just degree specific. So for the bachelor's, we have 1,348,503. And the doctorate recipients, we have 46,024 in total. And so in taking the numbers and adding together, so for the bachelor's again, you have this much out of 1,907,172. And the doctorates, okay, we have 46,024. So we have for the combined total in this particular case, okay, we have 394,527. Again, out of all the 1.9 million plus degree recipients. Okay, so this would be the ratio. And as for what we have as a decimal value, okay, this comes out to about a 0.731, about 73.1%.